So we're going to see another example for unit testing. This time we'll try to expand the concept a little bit, and to do that we're using a program that it's going to check if a given number is a prime number and what is the next prime number given a number. They're just the same for a random reason, okay? So said that, let's take a look at how this functions. The next, print and x prime and is prime, they were executed. So in our class prime here, we're going to do the following for is prime. We're going to take that number, we're going to verify for all the elements in the range of 2 in the given number if the modulus or the remainder is equals to 0. If that happens, it means that this is not a prime number, so we're going to return false. Otherwise, we're going to go there and return truth because that's a valid prime number. And to print it out, the next prime number, we're going to take the number, add 1, and we're going to call the previous function to do the verification and print. If that's true, we're going to go there and return the proper number which is next to the one that was provided. Okay, so if we go there and execute our code like this, we see that 42 is clearly not a prime. It's divisible by 2, by 6, and so on. The thing is, and when we provide 42, the next prime number is 43, which is correctly defined as a prime number. So everything seems to be working, right? So what happens if we provide our function here is prime equals to 0? And let's run our function here, our program, and we'll see that this is equal to true, but not exactly, right? I mean, everything is divisible. 0 is divisible by anyone, so it's clearly not a prime. So we should have a test, and our function should work in this way to make sure that this is correctly handled, right? And to do that, this is one way of doing TDD. And you start by doing the tests before anything else. So how are we going to do this? We're going to have a default function there. And that default function, we're going to try to handle this here by saying, well, this is test is 0 not prime. Oops, I have an extra space here. And then we're going to go ahead and create our test case. So first of all, we need to make sure that we instantiate an object from the class that we are trying to verify there. And then what is the main thing here? We want to assert that if you provide a 0, that's going to be a false, right? So we say assert equals, in this case here is assert false. And what we want to do, we want to call our function, in this case punit is the object, and we're going to call the is prime, and if we provide 0, this should return a false, right? And then let's go ahead and execute our test units just to see if our function is actually prepared to handle this kind of situation, all right? And as you can see, we have other test cases defined. In this case right here, we are checking out if 5 is a prime number, 4 is not a prime number, and we test the next prime. And how we do this? First, if we provide 5 to the is prime function, we should return truth. So we check it out if by calling this, we are searching for truth. This is pretty much the same thing, but for false, we do for 4. So if we provide 4, we know that 4 is not a prime, so we should return a false. And if we want to test the next prime, I want to search that whatever I receive when I call the function print next prime with a certain value, in this case 4, the next value it's going to be a 5. Okay, so but in any case, let's go ahead and just see how this will behave. Now let's run our case here, and something bad happened. And what was that? As we can see right here, we have some assertion that was true, of course, because the test 5 is prime, test 4 is non-prime, and test next prime, they all work without any trouble. But then when we try to see if test is 0 not prime, we receive an error. And why that? Because we were expecting to receive a false when we provide a 0 to the is prime function. So what we have to do there, we have to make sure that is prime is properly designed in a way that it's going to be false in case it receives a 0, right? So what we have to do is we have to modify our function for this to be true. So the first thing we have to do is if number, in this case here, in 0 and 1, because we didn't test 1, but it's the same case, right? I mean, 1 is not prime as well. So if we receive either 0 or 1, we should return false. And that's the expected behavior from our function, right? So now that we have altered the is prime function, let's go ahead and take a look on test prime to see how our new test case right here behaves, right? So if we go ahead and run our test case right here, let's begin here. And if we run that, we see that all 4 test cases, they were executed without any trouble. So we can see that test is 0 not prime here. It was executed without problem because we verified by calling the function is prime and we pass as 0, a false should be returned is exactly what we are testing here, okay? Try to design a test case in case you receive a negative number. So design a test case right here and try to assert equality, in this case assert false. If you receive a negative number, it should be able to handle, okay? We're going to include the answer for this in the whole code, okay? So thank you and happy coding.